Alrighty, welcome to my presentation on my flight simulator. Let's get started. So these are the equations of motion that my flight simulator uses. There's one main assumption built in is that there is no wind in the flight simulator. We'll talk a little bit more about other assumptions that are built into my flight simulator, but these were equations developed by Phillips. And on the right you can see a picture of the F-16. That's an actual F-16, that's not from my flight simulator, but we'll talk a little bit more about that later. These are the equations for the aerodynamic model developed by Hunsaker. There's a few assumptions built into them. A couple of the main ones are small angles as well as symmetry of the aircraft across the XZ plane. And so these coefficients in this model were developed for the F-16 aircraft that I'll show in my flight simulator. They were developed using an aerodynamic database of the F-16 aircraft. This database was developed by NASA. These coefficients were determined from linearized approximations from that database. The stall model in my flight simulator was developed by Beard and McLain. There's the equations right there for you. So there's a couple assumptions. The first is that there's a sigmoid transition between the non-stalled and the stalled region of the aircraft. And the second assumption is that after stall, the aerodynamics of the aircraft can be approximated using flat plate aerodynamics. And over there you can see a nice video of what stall is on a wing. So in my simulator, I use a blending rate of 100. Shown down in the bottom, and I also have a stall cutoff point of 25 degrees. That's my stall transition point. The ground effect model was developed by Phillips and Hunsaker using lifting line theory. So I use this model just in a first iteration approximation. It is preferable to run through and do multiple iterations. However, it didn't seem to improve the overall accuracy of that solution, and I assumed that within the accuracy of my flight simulator it would be negligible, and so I've been using that. Down in the bottom are the parameters for the F-16 that I found that were determined by Fox, with an aspect ratio of 3 and a taper ratio of 0.2275. Alrighty, so getting into some of the things that I've added to my flight simulator. The first is an auto trim capability. So this uses Newton's method to iterate to remove the forces and moments on the aircraft with control surfaces and throttle settings. This auto trim can be turned on and off. Now the aircraft comes into the flight simulator trimmed, but you can move out of that trim state, which will be shown in another video. The nominal values on the controller are used as the baseline trim setting, and when the user commands a control, it adds that control difference to the current control deflections. And when when the user lets go, they return to that nominal setting, and the aircraft trims itself in that condition and updates that current trim condition based on those current deflection values. All the trimming is done for a steady coordinated turn. Once again, you can exit out of the trim whenever you would like. So there's two objects in my flight simulator, two main objects besides the field and the sky. Well, just the field. The first is the aircraft shown on the right. It's the F-16 painted not too artfully like the Thunderbirds. And on the left is the bullets that my aircraft will shoot. Those bullets follow projectile motion. There's no aerodynamic consideration in iterating propagating the motion of those bullets forward. It's just projectile motion, basically adding in gravity so that the bullets drop, and stopping rendering them after a short while, which I'll mention in my other video. Further development of my flight simulator, I would love, I don't know if you as the audience have seen Tron Legacy, but I would love to be able to simulate, make a game out of that last part of the movie where there's two aircraft. Well, there's multiple aircraft, but they have contrails, and you hit the contrails, you die, kind of like Snakes, but in a 3D aircraft setting. I think it's really cool. That's what I would love to add to my flight simulator. So make it more of a game, make it 2-player, make it a 3D Snakes game, and adding contrails in there, along with adding a sky and other object collision detection. Thank you for listening, and stay tuned for the video on my flight simulation demonstration.